Welcome to a new PigCast from MSD Animal Health. I'm Rubén del Pozo, the Technical Director for Swine at MSD Animal Health for Europe. And today I'm very pleased to welcome here Dr. Héctor Argüello, who is coming from Spain. He's veterinarian by graduation and researcher at the University of León. Welcome, Hector, and many thanks for accepting to be here in our PigCast.
Thank you very much, Rubén. Well, just to introduce myself to those people which are in the other side of the screen or the mobile phone. As Rubén said, my name is Héctor Argüello. I'm a PhD in veterinary sciences. I did the degree at the same university as Rubén, so we are all colleagues. We share a lot of hours in the library.
And also in the Húmedo, in the barrio Húmedo de León.
Yeah, I was going to say that as well. Going from path to path. I did there my PhD, and then I moved to Ireland for 3 years doing some research in Salmonella. Back to Spain, to University of Córdoba, working on Salmonella pathogenesis as well. And finally going back home. I'm from León, from the same city as the university. And right now I'm lecturer there at the University of León, where I research in the Animal Health department. And apart from my degree, I collaborate with EFSA in public health issues. I also have collaborated with FAO in Salmonella things, and I'm diplomate of the European College of Veterinary Microbiology. My research lines are always linked to the pig intestine, to the pig gut, in something we are going to discuss today. Of course, really stick to Salmonella for many different years, but now opening another lines in swine dysentery, ileitis, PDV, and also the interplay with the microbiota of these pathogens and the intestinal health.
Well, this is a very impressive CV. So I'm happy to have you here today. Thank you very much for this nice summary of your career. And also, as you say, we are also friends from the school, so it's also a part of personal feeling to have you here today. So maybe we can start. You can explain us a little bit about your current research area. I have seen that you mentioned at the beginning that gut, pig intestine, those are topics that at least when we were students, this was not very hot topic. Most of the pig veterinarians, we were focused on reproductive disease, respiratory disease, the porcine respiratory disease complex, so I would like to know a little bit more, and I'm sure that all our colleagues that are listening to us today, they would like also to know a little bit more about your research in this gut health.
Yes, you are completely or absolutely right. When I started my PhD in Salmonella and in the gut, I said, I would like to research on respiratory complex, because at that time was like, wow, this is the fashion thing, you know.
Yeah.
And the gut is something secondary, but well, things have turned a little bit, and thankfully to microbiome things that we maybe talk about later, the gut has become something really important and really interesting. Now we are removing antibiotics, that is helping bugs to bloom, like E. coli, so it's giving a lot of problems to vets, and it's providing some new research areas for people like me. What I'm really interested in right now is to explore a little bit more about the disease pathogenesis. If we give an example, for instance, if we see the pathogenesis like a puzzle, we build that puzzle with pieces, okay? On one hand, we have the pathogen. We need to understand which are the virulence mechanisms. In some pathogens, we know which virulence mechanisms they have. For instance, enterotoxigenic E. coli, we know exactly what it's doing in the gut.
So this will be a little bit the old school of the science on gut diseases?
Exactly. And we have the pathogen and we have the host, and we know the host response. But for many years, we have not paid attention to a third player in this interaction, which is the microbiota.
And this will be the new guy playing a role in here. Okay.
So we have to introduce in the equation the microbiota to have a full picture of what's going on in the intestine. And this is a really interesting issue or research line in which I'm getting involved right now with different pathogens. I began with Salmonella. I have done things with post-winning diarrhea. Now we are working hardly in swine dysentery and also doing some things in ileitis, so this is my idea to start with. Yeah.
So you mentioned a word, microbiota, microbiome. I know that this is now a very, very hot topic. So everyone is speaking, we're starting speaking about microbiome, microbiota. When we speak about gut health, this is the main word that you hear everywhere. I'm sure that many of our people listening to us, many of the audience, know already what is microbiota, but it could be that we have some other people that are not veterinarians or they are not really involved on that. Could you explain us a little bit more with regular words what is microbiota, the difference with microbiome and intestinal flora, for example?
Okay, well, strictly speaking, generally speaking, better than strictly speaking. Generally speaking, they are synonyms: microbiota, microbiome, and gut flora. Strictly speaking, from a scientific point of view, microbiota are the organisms which are in a specific environment, in this case the gut, okay? When we analyze them with sequencing methods, when we analyze the genetic information, the DNA of these bacteria, because not all of them can be cultured in the lab, okay? When we analyze them by the genetic information, we talk about the microbiome, strictly speaking, okay. But they are synonyms.
And sorry that I interrupt you. When you speak about those microorganisms that are in the microbiota, we are speaking about bacteria or also other different microbes?
Well, microbiota refers to bacteria, but of course we have the virome, which is the genetic information which are in the viruses, and we have the funginome, which is about the fungi, and then we have the protist. Of course, everything can be involved in microbiota, but 99% of the time when we talk about microbiota, we talk about bacteria.
Bacteria, okay. Yeah. Now I understand.
I want to add one thing, Rubén, because now we have the chance in the podcast. So, message to take home for those people who are listening to us. Flora is an old-fashioned word. I tell my students at the university that we don't have any more flowers in the intestine. So don't use, please, at least with the people like me who are working in this topic, the word flora, because it's not useful anymore. We talk about microbiota, which is more fashion than flora.
Yeah, so we have now the microbiota. We understand what is the microbiota, and you were trying to explain the microbiome when I interrupt you. So what is the microbiome in?
Well, I'm going to try to give an example. Before having these new sequencing technologies, I'm a vet, so this is even to me hard to explain, but we now have machines that are able to sequence all the DNA which is in a particular sample, for instance, the feces. Before that, we were just able to get information from those bacteria which were domesticated, as I say, that we were able to grow them in the lab. Suddenly we have these new techniques and we get information not only from those bacteria which are in the lab, but also bacteria which are not culturable. And we realize that over 90% of the bacteria which are in the feces are non-culturable. I always give the example of an iceberg. If you see an iceberg, culturable bacteria are the tip of the iceberg. So the information we were having was really low. And now we have the information of the microbiome, that those bacteria which we don't see because we don't see them, but we know they are there because we have their fingerprint, the DNA of their genomes. And with that information, we know who is there and what they are doing there.
Okay, now it's more clear. So I would like to ask you a question now that I receive many times from the field. I'm totally sure that you have gotten this question also thousands of times. So I would like to know also what is the difference between, or if we can say in real life, if we can say that there is a difference between bad microbiota and good microbiota or beneficial microbiota. What is the definition for this, or how should we speak when we speak about bad microbiota and good microbiota? Is there a proper way to see that, or is there any difference between them?
It's an interesting question because it's really complex. We can talk, well, to be sure about bad microbiota, we have the usual suspects, the pathogens, okay? They are bad microbiota, we know that. But what we still don't know is what is a balanced microbiota or a proper microbiota compared to a bad microbiota, as you said. With the information that we have right now, I'm pretty sure, or I can put my hand on this table to say that there are certain bacteria that we already know that are desirable. That probably is the right word. Desirable bacteria in the gut.
Desirable bacteria.
Yeah. For instance, Faecalibacterium praunici. Yeah, it's not an easy word. I have tried different times and now I'm able to pronounce it. Faecalibacterium praunici. This is a good bacteria. Why? Because Faecalibacterium interacts with the enterocyte in the intestine and stimulates the production of interleukin-10. I don't want to be really scientific in this podcast, but what is interleukin doing? Interleukin-10 is an anti-inflammatory interleukin. So it buffers the inflammation in the intestine. Inflammation is never good. It's never good for intestinal health. So this bacteria is buffering the inflammation in the intestine. On the other hand, this bacteria and others are able to produce butyrate. Butyrate is the best short chain fatty acids we can produce in the intestine because it fuels the energy metabolism in the enterocyte.
Later on,
yeah. So the intestine is happy to have this bacteria there. This is an example. Others, Megasphaera, Veillonella, some Prebotellas, but in Prebotella, for instance, this is another group of bacteria. It's a really large group. Some of them seem to be really interesting and really good, some maybe not.
Yeah.
So we still lack a lot of information about that. Yeah.
So from now onwards, we should be speaking about desirable microbiota or undesirable microbiota or
desirable bacteria in the
within this microbiota. Yeah. That's it. So another question that I would like to ask you, because you are today here, so I think it's the best opportunity for that, will be, it could be that when we look into the physiology of the gut physiology of the piglet, that there are very clear phases, stages in the physiology of the animal. So just at birth, before weaning, they are drinking milk. So we have another physiology compared with the post-weaning period, where the milk is not present anymore, and the gut needs to adapt physiologically to different, to the absorption of different nutrients. Compared with an adult is totally different. So from what you say, I can understand that the desirable bacteria at weaning or before weaning cannot be the same, or cannot be maybe desirable a little bit later. What is your insight in this?
Another interesting question. Thank you. That's completely true. The microbiota evolves from birth to marker weight, and there is a transition and a maturation of the bacteria which are in the intestine. Each production stage is linked to a particular bacterial groups which are using the nutrients that we are using in the feed of the animals. For instance, as you said, during lactation, feed is going to be provided by the mother and it's going to be the milk. At that stage of animal's life, there is a bacteria called Bacteroides which likes the oligosaccharides of the milk, and this bacteria is going to dominate the intestine of suckling piglets.
So this Bacteroides is a beneficial,
desirable bacteria
in lactation.
In lactation.
Okay.
Lactobacillus is another example. After weaning, we drastically change the feed supply, and we remove milk and we provide nutrients in solid feed with a lot of fiber. So new bacteria which are able to degrade or to use that fiber, for instance Prebotella, we mentioned before, Faecalibacterium, Megasphaera, are going to colonize the intestine.
So they became more desirable, we can say in that way?
Exactly. Okay. So some bacteria, like Bacteroides, which are useful during lactation, are not useful anymore.
And they decrease.
Another example is Oscillospira or Lactobacillus. And we need a transition, a maturation from those bacteria to these fiber degraders that we have mentioned. When we don't have that, I have noticed in some of my studies that animals are more prone or are more susceptible, for instance, to get infected by Salmonella. when they don't have this change of milk-oriented microbiome to a complex carbohydrates, the degrading microbiome. Yeah.
Okay, because I understand that in some way this desirable bacteria from the microbiota will help to digest these complex polysaccharides, so preventing the colonization from the undesirable bacteria, or providing an atmosphere in the gut that is beneficial for the desirable bacteria and restrictive for the undesirable bacteria. Is that correct?
Here we can introduce a term which is pretty interesting, is the competitive exclusion.
Okay.
These bacteria, what they do is colonize the intestine. As I said before, they interact with enterocytes, they produce butyrate. Butyrate on one hand decrease pH. Enterobacteria, Salmonella, E. coli do not like this low pH in the intestine.
Okay.
On the other hand, this butyrate is used by the enterocyte, and the enterocyte release carbon dioxide into the gut lumen. So it creates an anaerobic environment. Again,
okay.
E. coli, Salmonella, they don't like it.
They don't like it.
So they establish a kind of barrier, a local physiological barrier against pathogens. So they support what they do with vaccination, for instance, against E. coli and other interventions that we are doing. They are helping us to prevent or control diseases or enteric diseases on farm.
Okay, so thank you very much for clarifying this to help and for helping us to understand a little bit more about the microbiota and the desirable and undesirable bacteria that we can find in this microbiota, and how to interpret that not always good is good and bad is bad. It depends on the situation and the production stage of the animal.
Yeah, another example is lactobacillus. A large amount of, lactobacillus is a desirable bacteria. We have it in our yogurts. When we eat yogurt, we eat lactobacillus.
True,
yeah, and it's kind of probiotic. Are all lactobacillus probiotics? Probiotic is a bacteria which benefits the host, in this case the pig or the human, okay? No, not always lactobacillus is a beneficial bacteria. We now know about these microbiota studies that some animals experiencing diarrhea after weaning, above all when zinc oxide was used, they have a dysbiosis in which lactobacillus was in really high abundance. So if we send a sample to a laboratory and they say, oh, the microbiota is good because you have a large amount of lactobacillus, it doesn't mean that lactobacillus is causing disease, but is telling us that there is a dysbiosis. What we need is an enriched microbiota with a lot of different bacteria present there.
And for us to understand, how will you define dysbiosis? This balance in between the different microbiota or the different bacteria in the gut, or how will you define this?
Well, dysbiosis is a disbalance of the gut microbiota. For the information that we have now, what we need in the gut microbiota, above all after weaning, is a dominance of this bacteria that we have mentioned before. But apart from that dominance of bacteria, we need an enriched environment, a lot of different bacteria present there. When a few bacteria are colonizing the gut, these animals are more weak against pathogens, more chances to get colonized by pathogens, and more chances to have diarrhea. So this is a disbalanced microbiota.
Okay, so we are opening here a door for discussion about the host interaction with the different pathogens and enteric diseases that you mentioned that you have experienced in your research. So, sorry, when we speak about Salmonella, we know, and I have listened to you sometimes saying that Salmonella in some way is able to modulate in its own benefit the microbiota that is in the gut, and from there to take some advantage to cause disease and multiply itself.
Mm-hmm.
Could you explain a little bit more to explain to us how this is possible in the real life in the gut?
Okay, trying to say in easy words. Imagine that Salmonella is going to a banquet, okay? The table with the food is the intestine,
okay,
and people who are eating in the banquet add bacteria which are there. And Salmonella reach the banquet and see that there is lovely food, there is caviar, there is seafood, there is good meat, but there is no chair for her. This is what happens in the gut with Salmonella. Okay. So what she's doing, she brings her own chair and she tries to occupy or create a space in the table. So Salmonella could look silly because Salmonella press the buttons of the immune response.
Okay.
So Salmonella is activating the alarm of the immune system, and the immune system realizes that there is a pathogen there, and immune cells migrate there, and there is a strong inflammation.
So it's triggering a kind of inflammation at gut level.
Exactly.
Level, yeah.
It could look silly. It could look like a suicide attitude of Salmonella, like come here and kill me. Well, what she's doing is completely the opposite. This strong inflammation goes against the commensals which are in the gut. So beneficial bacteria, all those bacteria that we have mentioned, Faecalibacterium, Megasphaera, Veillonella, Prevotella, even Lactobacillus are removed from the intestine, and Salmonella gets the chance to put the chair and have all the banquet for her. This is what she's doing.
What she's doing. And another pathogen that could be also related with the gut disease is Lawsonia. And we know that Lawsonia in some way can also modulate in his own benefit. Could you explain also with this easy words what is doing Lawsonia? I know that there are not a lot of research on that, but what are the hypotheses on this nowadays? Yeah,
well, unluckily we don't have that much information with other pathogens as we have with Salmonella. Well, Salmonella is the gold standard because it's a zoonotic pathogen. It goes to carcasses, and we have invested a lot of money. Unfortunately, we are not paying so much attention to, for instance, Lawsonia, the silent thief of the intestine. But we have some studies on it, and interestingly, Lawsonia is a pathogen which likes to be silent. Okay. So it colonizes the gut, but it doesn't make any sound. So in the first stages of the colonization, there is no any inflammation in the gut.
Is there? And is
exactly. But even without inflammation, we don't know the mechanisms yet, but we know that there is a depletion in the mucosa of these bacteria which are desirable, these bacteria which interact with enterocytes. Okay? Probably because Lawsonia is stealing energy from the enterocyte, so there could be some disbalance in enterocyte physiology, okay? And these bacteria lack the mechanisms by which they interact with the enterocyte. I don't want to get really complex on that. On the other hand, in the gut lumen, when we have a large amount of Lawsonia inside the enterocyte, we know that there is a depletion as well of these bacteria which are producing short-chain fatty acids. And this is pretty important because I also do diagnosis in the lab, and I always, when I have an infection, either Salmonella, either Brachyspira, I always tell my PhD students, please do the PCR for Lawsonia as well. And it's always there. Lawsonia is always there. And probably it's helping the other pathogens to establish and colonize the gut.
To break the stable situation.
I don't know if, well, you are more a clinician than me, if when you send samples to labs and you perform arrays of diagnostic tests, you see this kind of disease complex. We call it the Enteric complex. We have the respiratory complex, but we also have the Enteric complex. I don't know if you agree with me that there is.
Totally agree. I was about to say that the porcine Enteric complex is something that we now start listening about it or hearing about it as the same that we heard in the 90s about the porcine respiratory disease complex. It's something that we see. And when you go into a farm and you collect fecal samples, you do PCR or culture, in most of the cases you find not only one, but you can find many. And Lawsonia is one of those many that are always combined with.
Lawsonia is more or less always involved. So this is something we have to externalize. I began my PhD in 2007, and at that time my supervisors, Pedro Rubio and Ana Carvajal, already were speaking about the Enteric complex like something usual and that they were seeing, and people need to know that when they analyze their intestinal problems on farms, pathogens usually are not alone. They usually are together, like in the respiratory disease.
Perfect. So I think we need to make more noise about this.
Exactly.
Enteric complex. So what I understand from this conversation, and almost now at the end, is that in some way we can provide some therapeutic measures whereas it's feeding or nutrition or adding different substrates to the gut that can be beneficial to control diseases. In the same way that years ago we were adding some antibiotics, I assume that in the future we will be speaking, or maybe now we don't need to wait for the future. We have different strategies that can help to control different enteric diseases, but adding something into the feed or to providing to the animal some prebiotics, probiotics, or different stuff. Do you have any example about it in any disease?
Another interesting question. I'm pathologist, so I'm not nutritionist or genetist, but I want to try to start by the beginning. As we said, we can, well, the microbiota needs to be seen as something that can be changed, okay? Something that responds to external stimuli. We have talked about the microbiota in lactation and after weaning and how feed is able to change the microbiota. As the microbiota matures, it's more difficult to modify it, okay? The bacteria which are established in the intestine become stronger, and we are not so good at modifying it by nutritional interventions. But it's true that in early stages there is a lot of plasticity. That's a word I like for the microbiota, and we can work there. Okay? So on one hand, if you talk instead to people who work in genetics, they also do a lot of research in microbiota and the genetics. They are pretty sure that in the future we are not going to just choose the genetics of our pigs. We are going to choose the genetics, and we are going to say, okay, with these genetics we are going to choose this microbiota because it's the best microbiota for this particular genetics. Okay? On the other hand, nutritionists, they are going to work with nutritional interventions like modifying the amount of protein, including more digestible fiber in the diet to favor this beneficial microbiota that we are talking about. And then, for instance, strictly speaking, which is your question about pathogens, we know that, for instance, with Brachyspira high on dysentery, in Brachyspira infection, if we supply feed with inulin, which is a prebiotic, is a complex saccharide, we prevent the disease, or we are in somehow seeing that animals do not get as sick as without inulin. What we don't know yet is which bacteria in the gut are using this inulin and is outcompeting Brachyspira. And this is pretty interesting for the future to develop strategies either with inulin, which is quite expensive, or using this bacteria, which maybe is cheaper, to have some preventive measures against the swine dysentery, which is a really bad disease on our farms.
So what I understand here, and just to conclude, will be that in the last years we got a lot of knowledge on nutrition, but in some way we should learn also not how to feed the animals, but also how to feed the microbiota that those animals have at the different stage of production. This could be one of the conclusions from this PigCast.
Yeah, well, it's a good conclusion. I can use another example. Hippocrates in Roman times said that all diseases began at the gut, and his hypothesis was more or less right. Like a good intestinal health provided by good feed supply, good management of animals, good husbandry, proper vaccination, and other measures that we can take on farm, is going to establish a proper microbiota, which is going to balance the intestine. So we do not need to pay just attention to the host health, but the intestinal health as well.
Thank you very much for the nice conclusion. It has been a pleasure to have this discussion with you, this talk. We could be here for hours. I think it's time now to say goodbye, to close this meeting, and thank you very much for coming in here.
Okay, the pleasure is mine too, to see you again at this stage and seeing that both are working with pigs and are doing well. And I want to say goodbye to everyone. I hope they have enjoyed the PigCast.
Okay, thank you very much, Hector. And now thank you very much all the audience for being listening to us here. And I hope to see you in the next PigCast, in the next PigCast from MSD. Thank you very much, and see you next time.
you.